Alrighty, here we have a pair of triangles that are congruent, or so they claim. No, they are. But it's up to you to verify that. And the only tool we have to verify that these two triangles are congruent is to find the lengths of all the sides and show that each side from this triangle matches up with a congruent side from the other triangle. And how do we find lengths in the coordinate plane? You've been doing that for a while. So, you're just going to basically calculate the lengths of all the sides. You can go ahead and label them. And then you'll have to find out that some match the others, and that's enough to show that they're congruent. And you will find that they do match. The second part of this is we want to know which parts match up. So I want to talk about what the parts of the triangle are. So on this triangle here, it has three sides, and they are side RP, and we put the line over top of it. That means segment RP, because that side is a segment. Over here, we have segment PQ, right? And then down here, we have segment RQ. And then down here on this triangle, we've got segment KM. And then we have segment LM over here. And then over here, we have segment KL. And by the way, it doesn't matter what order you name the segment in. I could call this KL or LK. It's the same segment. KM, MK, same segment. Doesn't matter. Okay. Next, we've got angles. And this is angle R, but I'm going to give it its more proper name, which is angle PRQ. PRQ, using that kind of wraparound name. And by the way, you can wrap around in either direction. PRQ is the same as QRP. And up here, we've got RPQ. RPQ, angle RPQ. That symbol there means angle. And over here, we've got angle PQR. PQR. Okay. And down here, we've got angle KML. KML. Angle MLK, MLK, and angle LKM. Angle LKM. So those are all the angle names. So 3 angles and 3 sides for each triangle. And you just need to pair them up. And by pair them up, if you want to write how they're paired up, then you would just use the congruent symbol for each pair. So angle congruent to angle. Side congruent to side. And all together you should have 6 congruent statements saying that each side over here is congruent to a side over here. Each angle over here is congruent to an angle over on here. Now finally, we want to know how it is, like if this triangle and this triangle are congruent, then there must be some way to take this triangle and kind of pick it up and move it over and place it on top of that one. Or maybe this one could be moved over and placed on top of that one. Would be either way. I think we are asked to show that. Let me check here. That a translation doesn't work. All right. So if you're going to show a translation doesn't work, you just have to figure, well, what are your matching corners, and show that whatever translation would take one corner to its corresponding corner doesn't work for the other corner. So they'd have to be different translations for each corner. And I think it's pretty obvious I can't take this triangle and just slide it up on top of that one. So it's something else entirely. So it's up to you to kind of figure out what that is. It might be more than one thing. Maybe it's like a mix of different transformations. Remember, the different transformations we've been looking at are translation, that's a slide, rotation, that's a turn, or a reflection. And that is a flip. It's a fancy word for a flip. And it might be some combination of those. Let's see what you can figure out. I think you can figure out. It doesn't have to be exact. You don't have to say exactly what line it was flipped over, rotate, or you don't say exactly where the center of rotation is. Just in general, how do you think the one triangle could be mapped onto the other?